Yesterday we have seen the phase rule equation, and you know the phase rule equation is F is equal to C minus P plus 2. F is equal to C minus P plus 2. This is the phase rule equation. And we have also seen that F is the degree of freedom, C is the number of components in the system which is in equilibrium, P is the number of phases, and 2 is constant. Yesterday one example was remained to explain before you that regarding to miscible liquids and immiscible liquids, if we take chloroform and water in a test tube, then these two liquids, these two solvents are not miscible. That is, they will not form a homogeneous solution. When chloroform and water taken in one test tube, then after thoroughly mixing, after strong shaking, you will see after some time that there are two different layers in test tube. One is chloroform and another layer is water layer. Even though there is a liquid state, but there are two phases, one belonging to chloroform and another belonging to water. In this way, state is liquid, but number of phases are two phases. Okay. Another example in which two liquids are miscible. Let us take alcohol and water. When in a container we take alcohol and water, and after a small shaking we get a solution of alcohol in water. These two liquids, these two solvents are completely mixed up into each other, and therefore here state is liquid and number of phase is also one phase. There are no two different layers of alcohol and water as like chloroform and water. In this way, our idea of phase or phases, I think you have now clear concept of this phase term. Another term of phase rule equation is the number of components represented by letter C. What is C? C is nothing but the number of components present in the system in equilibrium. Number of components present in the system. Actual definition of component, that is C, is that components of system is nothing but the minimum number of independent chemical constituents. Minimum number of independent chemical constituents in terms of which composition of every phase in the system can be expressed. What is component? Component is nothing but the minimum number of chemical constituents which are required to express the composition of each and every phase in the system. This idea of component will be clear when we will see the few examples, as like in case of term phase. The idea becomes more clear about component or number of component, that is letter C in the phase rule equation. There are some rules. There are some rules for the number of components. The first rule is that the chemical formula representing the composition of phase should be written on the left hand side. The composition of phase is represented by a particular formula, and that formula should be represented or should be written on the left hand side. As you see, different types of chemical equations, different types of chemical reactions, you write the chemical reactions. There is an arrow. It may be single arrow or it may be reversible arrow. There are some spaces on the left hand side and some spaces on the right hand side. In the same manner, here when we discuss the idea of component, for a particular phase, the formula representing that composition of phase should be written on the left hand side, and the other constraints, other components which are necessary to represent this phase, to represent this formula, are written on the right hand side. Simple chemical equation, as like mathematical equation, as like chemical reaction, reactants, arrow, products. In the same manner, the phase of which you have to express composition, the formula for that phase on LHS, and the other chemical components, chemical constants which are necessary to express this phase are written on the right hand side. This is the first rule. All this idea of component will become clear as we progress ahead by taking number of examples. We will see later on the examples. The second rule is that I have explained here. The rest of the chemical constants existing independently in the system are placed on the RHS. Suppose there are 3 chemical constants in the system. Suppose there are 3 chemical constants in the system, then the other remaining constants should be written on the RHS, that is right hand side. And the formula which is going to express the composition of the phase which you are studying is written on the LHS as given by first rule. Second rule is that the independent chemical constant should be written on the right hand side. And the third rule is that the quantities on the right hand side, the chemical constituents on the right hand side, there may be addition, subtraction, or there may be a coefficient 0 of some constant.